Hey boys and girls, this is Miss Bada. These are going to be the notes for section 14.4, which includes pages 436 to 441. As you can see in the first one, this kind of closed pathway that follows a fixed pathway, starting point, ending point are the same. This is what we call a circuit. This is like what a roller coaster would be. An electric circuit is simply a closed path through which electric charges flow. And all simple circuits need three basic parts: an energy source, wires, and a load. Loads are things like light bulbs, radios, microwaves, computers, Xboxes, TVs, anything that is powered by electricity. And loads change electrical energy into other forms of energy. Now you see down below here two diagrams that include a switch. You have your energy source, your wire, and your load. Now, you can have a complete circuit without the switch, okay? So just remember that. But with the switch, you'll see in the first picture, the switch is closed or down. The electric charges are allowed to flow through from the battery to the wires to the load, and the bulb will be lit. In the second diagram, where it says the switch is open, there is a gap between where that switch is pulled up. And so this gap prevents the electric charges from traveling through it, and electricity is not going to jump that gap. So that's the same as when you flip on a light switch or flip off a light switch. If you flip the light switch off, you've opened the gap. When you flip the light switch on, you've closed that gap, and the current is able to flow to the load, which would then be the lights. Excuse me. So when we say if a switch is open or off, the loop of the circuit is broken, and so electricity can't flow. Now, the two types of circuits are series and parallel circuits. The one that you see on the left is a series circuit. In a series circuit, all parts are connected in one single loop. I like to think of it as there's one path for all the current or the electricity to follow. All of the loads in a series share the same current, and a series circuit then has only one pathway for the moving charges. So it says, why would a series circuit be a bad way to wire your entire house? I didn't answer this for you because I want you to answer it. Think about all the things that were talked about in class when it comes to circuits. Think about why this would not be a good idea to have your home wired in a series circuit fashion. One good use for series circuit would be burglar alarms. Now think, why would you need burglar alarms to be wired up in a series circuit? And we'll talk more about this in class. Next we have define a parallel circuit. Well, this is one where the loads are connected side by side, or there are more than one path for the electricity to travel through. It's kind of like they're in branches. So there's more than one way that the electricity can flow. All of the loads in a parallel circuit then do not share the same path or the same current. And so in a parallel circuit, each branch of the circuit can work by itself. So why would a parallel circuit be a really good way to wire your house? And I'm going to let you answer this one. Okay, one of the other things we talk about are short circuits. So in a short circuit, charges do not go through one or more of the loads. Maybe your light bulb burns out in your kitchen. The current is now not able to flow through, okay? And in some instances, you need to check at your house, ask your parents and they should be able to tell you, do you use fuses or do you use a circuit breaker? My house has a combination of these, but a fuse is a thin metal strip of metal. It's a thin strip of metal. Charges will flow through this strip. If the current gets too high, the strip will melt. And so as the result, the circuit's broken and the charges stop flowing. With a circuit breaker, this is a switch that will automatically flip open if the current is too high. What happens here, and I'll show you some videos of this, a strip of the metal in the breaker warms up and bends and opens the switch, and that opens the circuit. It kicks it off or open, and so the charges stop flowing. Now these are all safety precautions, okay? Nobody wants to have a house fire. And then the last thing, GFCI, ground fault circuit interrupter, acts as a small circuit breaker. Some of the newer hair dryers have GFCI in the outlet, not in the outlet, in the plug-in. If you notice when you go to plug it in, you may see a red button or a black or gray button. That's a GFCI. If the current in one side of an outlet is different from the current on the other side, the GFCI opens the circuit, it kicks open that circuit breaker, and the charges stop flowing. Again, all of these are safety precautions. Now, this ends the last page of this, and it looks like I may have put this on there sideways, so if I did, I apologize. If you keep running this, I don't know what I did. I messed something up somewhere, obviously, but you will see me writing over the things at the top, but you'll see that I'm writing the same things. So if you've gotten this side finished and you've answered the 2 questions that I wanted you to answer, then you're finished with your guided notes. Talk to you later. Bye.